everyone, this is Mrs. Amoroso, and I just want to talk with you a bit about the science that we use today to launch our bottle rockets into space. Basically, this is the same science principles that NASA and SpaceX use every time they launch their rockets into space. So, when we just launched the Falcon 9 on May 30th, they use the same basic principles that we use today. So, basically, we used Newton's third law. Sir Isaac Newton was a scientist back in the 1700s, and he basically transformed our notions of gravity and motion forever in science. Today, we use all of his laws. Anytime you're moving, you're probably using one of Newton's three laws. So the one that we mostly talked about today was for every action, there is an equal and opposite reaction. So rockets work by ejecting something out of the back, which would be your action, and then a reaction force then pushes the rocket forward. So in the diagram that you see, we have a black arrow pushing out to the right and a blue arrow pushing to the opposite direction to the left. So the black arrow represents your action. That is usually some type of combustion going on, usually with some type of fuel. And that exhaust then is pushed backwards. And the reaction and the opposite equal reaction is then the blue arrow pointing to the left, showing that the engine is pushing forward. For us, we used water and air pressure. Now here, the water and air are shoved out the back. The water is heavier, so that's what gives the bottle the main force, the main kick that you saw, the main action that propelled the rocket up into the air, the bottle into the air. The energy to force the water out is stored as air pressure inside the bottle. So what we did was we pumped air into the bottle, and the bottle already had air in it. So this was additional air into the bottle, causing it a lot of pressure inside the bottle, pushing on the water. But the water couldn't go anywhere because it was locked into place with a clip. And that clip was being controlled whether it was hooked onto the bottle or it wasn't hooked onto the bottle by a string. So once we pulled the string, then that allowed the water to be released. Once the water was released, the air pushed down on the water, it released out the back. That is your action. Your reaction was the bottle being thrown into the air. So the air pressure built up, we released it. Once it was released, you see this big water plume coming out, which you see in the slow-mo video. And that water plume is the action. And then your reaction was the bottle going up in the air. We hope you had fun because we did.